Hey, welcome to this week's session where we are going to discuss binomial distribution. So, like I said on Saturday, please remember to bring your statistical tables because we are going to use those. Where to find the statistical tables, either in your prescribed textbook or they would have sent you a tutorial letter with the statistical tables. Otherwise, you can find them in the past exam papers like before COVID. COVID was in 2020. So if you can get hold of a past exam paper from 2019 upwards to 19 something, then you will find the statistical tables in there. So yeah, let's get on to it. So by the end of the session today, we will cover the properties of binomial distribution. You will learn how to calculate the mean and the variance and the standard deviation of a binomial distribution, and then you will also be able to calculate the probability linked to a binomial distribution. Now, before I even start, I just also want to make you aware that in terms of your module, you are expected with everything that we do, you are expected to know the content in terms of the properties, and you have to learn to know how to do some calculations. So you cannot get away from it because some questions in your assignment or in your exam might be phrased in a content type of a question where they ask you basic things like the properties of a binomial distribution, or they might ask you to calculate the mean, or they might ask you to calculate the probability. So you will never know. You need to know everything about binomial distribution. What is a binomial distribution? It is a sequential number of trials from a sample space. For example, when I am tossing a coin, so a binomial, if I might also take one step back, binomial means 2 by 2. So it means there are two things. There are two outcomes that can happen. So for example, when I toss a coin has two sides or two outcomes that a coin can land on. It can either land on a head or it can land on a tail. But not only just a coin, you can do a binomial trial by means of looking at a success or a failure as well. So there will always be two outcomes, and those two outcomes, one of the outcome, we will refer them to a success, which will be the outcome that they will always give it to you in terms of the your statements in your questioning. They will tell you that the probability of success is this much, or they will give you the amount satisfying that probability of success and the sample space, and then you can calculate what that success probability looks like. But there will always be two outcomes. One is success, and one is a failure. And the probability of success will be denoted by a pi, and the probability of a failure will be the complement of that pi. So it will be 1 minus the pi. For example, we've learned in the basic probability that if I have a coin, a head is a complement of a tail, or a tail is a complement of a head. So if I toss a coin and it lands of a head, that is a success for a head, will be 1 out of 2. And the complement of it will be a tail, which will be 1 minus 0.5, or 1 minus 1 over 2, because there is the number satisfying, which is 1, divided by the sample space, which is 2 outcomes, which is the total number of outcomes. So if we're looking at the product, then we will have a defective product or a non-defective product. So it means if I work in a factory and I need to calculate the probability that we will always produce a defective product or a can or a bottle, then I can calculate it by looking at the number of defects versus the number of success, which are the non-defective bulbs. And like I said, the two outcomes needs to be independent, but they also needs to be mutually exclusive and collectively exhaustive. So therefore, it means they have to include all the other observation. Please make sure that you accept anyone who sits in the lobby. And the event has to be independent from one another. And remember, what does independent mean? Independent means one event does not have any effect or does not affect the other event happening as well. Okay, so what are the characteristics that you need to know about binomial distribution as well? So we need to learn how to calculate the mean of a binomial distribution, which will be given by your mean or your expected value is your number of the sample space multiplied by your probability of success. Multiply by the probability of success. And the variance will be given by the sample size multiplied by the probability of success times the probability of failure. And the standard deviation will just be the square root of your probability, your variance, which will be the square root of your sample size times the probability of success times the probability of failure, which is the complement of success. Okay, so let's look at how we will calculate this. A student is taking a multiple choice exam, and there are 4 multiple choice questions, with each question having 4 choices. So there are 4 questions, with each question having an option of one, where one question is correct and the rest of them are not correct. So therefore, it means we are given also the observation satisfying success will be 1, because one question will be correct. So in order for us to calculate the probability of success, we are going to say our x, so our probability of success pi, will be given by outcome satisfying that divided by the sample space. So the outcome will be 1 divided by 4 because of the 4 choices. So for each question, there is a probability of 4 questions. So it means the outcomes of 4 questions, of which one of them is correct. So therefore, we can calculate the probability of success as 1 divided by 4, which is equals to 0.25. So our probability of success is 0.25. Now let's answer the question. The first question is find the mean. And we know that the mean is your sample size, which there are 4, times your probability of success. Therefore, the answer here will be 4 times 0.25. And that will be equals to 1. And to find the variance, and the variance is the sample size times the probability of success times the probability of failure. Therefore, it means it is 4 times 0.25 times 1 minus 0.25, which then it means the answer is, let me find my calculator, that we can calculate. Just give me a second. I need to find a calculator. Okay, so from my calculator. So it is 4 times 0.25 times 1 minus 0.25, which is 0.75. And it is equals to 0.75. And to calculate the standard deviation, we just take the square root of 0.75, and that is 0.866, which is 0.87. And that's how you will find the mean, the variance, and the standard deviation of a binomial distribution. So how do we find the probability? Remember, we discussed this on Saturday. You need to know that sometimes they will give you a mathematical symbol, or sometimes they will give you the meaning of that mathematical symbol, which makes it easy to know and navigate and know how to answer the question. But most of the time, they will give it to you in a word phrase, which you need to link the word phrase to the mathematical function so that you know the meaning of that function would be. So you need to know what exactly mean, you need to know at least mean, you need to know at most mean, you need to know exclusive mean, between exclusive and between inclusive mean. So all of them, very, very important. So if you forgot about them and you didn't take a screenshot the last time, now is your chance to take a screenshot, because you're going to refer to this as we do some activities later on. So make sure that you know the meaning and the word phrases. Okay, so how do we then do the probabilities? So in order for us to calculate the probabilities, we have to use a probability function, distribution function. And for a binomial distribution, the probability distribution function reads as follows. Before I explain the probability distribution function, I want you to picture yourself playing Lotto, because I'm going to explain some of the components that makes up this probability distribution function. Think about yourself playing Lotto. Now, you know that Lotto is a game of odds, a game of likelihood. You know that it got, depending on which one, but let's use the normal one where you have 1 up until 49 balls that you can select 6 out of them. So it means in terms of binomial distribution, so you can calculate what we call the probability of winning and the probability of losing your lotto, right? So let's see how that applies in this instance. So for example, let's say I want to know how many chances I'm going to win lotto if I bet on certain numbers. So the probability distribution function gives you 2 parts to calculating that probability. The first part, which is this part, is a combination part, which tells you how many number of ways can you win lotto based on the number of outcomes that you have. So you have 1 to 49 outcomes that you need in order for you to win lotto. So we can calculate the number of ways by means of that. If I know the probability of a certain number, which is a certain number that I am choosing, what is that probability of that number being chosen to become? Then I can use the part where I calculate the probability of success and the probability of failure to get to combine the number of ways times the probabilities to get to a probability distribution that will tell me what are my chances of me winning a lotto, so that I can stop wasting my money and stop playing lotto because I'm not I don't even have a good chance. Maybe I've got 0.0001% of winning the lotto. So I'm just wasting my time. So that is the formula you can use, especially for those ones who like gambling. You can use this. It can give you some insight into your gambling behavior, but I'm not promoting that, right? I am not promoting gambling by means of binomial distribution formula. Okay, so the simplest way that you can use in order for you to save time in the exam, instead of using that formula, which is complex, I will suggest that you use your statistical table. But there is a catch. You need to know how to read your statistical table in order for you to be able to use it. So, how does your statistical table for binomial distribution looks like? It is called Table E6, and you can find it in your past exam papers or in your prescribed book. So, it's also called Table E6, the table of binomial probabilities. So you need to be able to know which table you are looking at by reading the name of the table. It is very important because from now on, as of today, until we end up with all the sessions, we are going to be introducing a table after a table after a table after a table, except with the last session. But you need to know how to read each table that we are going to give it to you or show you. So a binomial distribution table is made up of two sides. It has the top side and the bottom side. You will see that it spills over 2 pages when you're looking at it on the table or on the prescribed book or on the past exam paper. Now, the two tables are connected to one another. So what does that mean? It means it's a continuation from the top to the bottom or bottom to the top. There are no breakages. So you need to read them together. When you use them together. Why I say that? Every number or every probability of success that is at the top is read with the probability or the n, which is your sample size and your x observation on the left. Every probability at the bottom is read with your n and your x observation on your right. So it means if you have a probability of success between 0.01 and 0.05 or 0.50, so if you have a probability of success of 0.01 up to 0.50, you will need to use the top side of the table and read your n and your x observation from the left. If your probability of success is between 0.5 and 0.99, then you need to read the values from the bottom of the table up using the n and the x observation on your right. I hope it makes clear or it makes easier or makes sense to you based on the explanation that I said. The top goes with the left, the bottom goes with the right. Always remember that. So we're going to look at doing the example of using both methods so that you are able to see which one you would want to use in the exam. Therefore, it means practice, practice, and practice. So let's look at this example. What is the probability of one success in 5 observations if the probability of an event of interest is 0.1? So what are they giving us? They are telling us that the probability of success is 0.1. We need to find the probability that at least 1 is selected, which is one of those success, and 5 is your n, which is the number of outcomes, and your probability of success, which is the pi, is 0.1. So to calculate that using the formula, Easy. Substitute the values into your formula. So we know that our formula is n factorial divided by x factorial times n minus x factorial times the probability of success to the power of x times the probability of failure to the power of n minus x. Now, this formula here, which I didn't touch in the previous section, you can simplify it by using NCR button on your calculator, where R will represent X and N will represent N. And you just press, for example, on this one, it says 5 and 1. You will just press 5 and you will press second function and you will look for that NCR and then press 1 and press equal. If you are using a sharp calculator, oh, sorry, a Casio calculator, this one is for sharp. So for a Casio calculator, you will say 5, shift, and you will press button number division. Then you will press the division sign, which has the NCR button, and you will press 1 and then press equal. That will give you the same. If you want to use the formula and use the factorial on the Casio calculator, you do have an x factorial. It is written like that. It will represent n factorial, x factorial, any factorial. You will use that button. Those who are using the sharp calculator, you will find an n factorial. You'll have to look for it. So, but all the functions are accessible from your calculator. So let's solve this. So we say n is 5, x is 1, pi is 0.1. We just substitute all the values, and n is 5. We just substitute and we solve. The combination gives us 5, because 5 factorial is the same as 5 times 4 times 3 times 2 times 1. 1 factorial is 1, and 5 minus 1 factorial is 5 times 4. Oh, it's 5 minus 1, it's 4. Then it's 4 times 3 times 2 times 1, which will cancel up the first one, and the remainder will be 5. Multiply by 0.1 to the power of 1. It is the same as 0.1. And 1 minus 0.9. 0.1 is 0.9. 4 minus 1, or 5 minus 1 is 4. And when you solve this, you get the probability of 0.32805, which is the probability. Now let's see if we can find this probability on the table. So let me see if my table has 5. It does not. It ends on 4. So I probably will have to use the table. So let's gonna go out from this side, discard, and I'm gonna go into a new sharing. We're gonna share. Let's stop and share a table, statistical table. Like I said, if you need access to this, I will share on the WhatsApp group as well, so that you have it for now and into the future. So this is our statistical table. Let me make it big. So what our probability of success? Our probability of success was 0.1, our n was 5, and our x was 1. So because my probability of success is 0.1, then it means I must look for it at the top. And when I look for it at the top, it means I'm going to use the left-hand side. So 0.1 is 0.10 on the table. N, I go and look for n of 5, is there on the table. And x of 1, I'm going to look at the x values. And there is x of 1. And where they meet, that is the probability we are looking for. Remember, our probability was 0.32805. So we do have our probability if we leave it to 5 decimals or 4 decimal. So that is how you will find the probability of success, or the probability of X is equals to 1. Now, let me put a spanner to the works and tell you, what if the question was, what is the probability of greater than 1 or at least 1? Then it was going to be a mission, because we were going to find the probability that X is greater than or equals to 1. And looking at this table, therefore, it means we were going to find the probability of X is equals to 1 plus the probability of X is equals to 2 plus the probability of X is equals to 3 plus the probability of X is equals to 4 plus the probability of X is equals to 5. Now it means if I'm going to use the formula, I was going to use NCR. Maybe let's just complete the entire formula the way it needs to be completed. Instead of using NCR, we use the actual values. Now my eraser doesn't want to work with me. I don't want to delete. I want to erase the values I wrote there. So we would have gone with our N is 5, C 1. Oh, for number 1 is 1, and 0.1 times 0.9 to the power of, this will be to the power of 1, this will be to the power of 4, plus, and we come to this one, we still have 5, NCR2, and you will get 0.1 to the power of 2, and 0.9 to the power of 5 minus 2 is 3, plus, and you will go on until you get to 5, where you will say 5 NC5, 0.1 to the power of 5 times 0, which is 1 minus 0.1, which is 0.9 to the power of 5 minus 5, which is 0. So can you see how long it will take you forever to calculate each and every number of probability that you have? But if you have a table, it becomes easier, because all you need to do is take from 1 and calculate it by adding all these values. So you'll just add all the values, and those will give you the probability of at least one value being chosen. Alternatively, instead of adding all the values, you can say the probability that X is greater than or equals to 1 is the same as 1 minus the probability of X less than 1, which means you're only going to calculate and say 1 minus 0.5905, which is equals to this probability of X is equals to 1, or X is equals to 0, which then it will give you the probability of greater than 1. That's the other alternative way of calculating this. So I want to move on from this. Let's go back to our presentation, unless if you have any question, because I'm done. Then we can look at the questions. Okay, so in the absence of questions, so we go back to our presentation and finish off, and then look at the exercise. So alternatively, if we have to use the probability of 0.75 as an example, then we go to the bottom page, and our N is 10. So we will go to N of 10. So this side will have N of 10 on the side, and our X is 8. And then we're going to read the table from this side and get to 8, because you can see that the X values from the bottom table reads from bottom and goes up. So that will be 8, and that answer will be the probability of 0.2816. Otherwise, you could use a formula and spend most of your time trying to figure out how to calculate it. But also, it is very important to know how to use a formula, because sometimes what I've learned over the years is that sometimes they just substitute the values onto their formula and they're asking you which option is correct. So you need to know both ways. But it doesn't mean when you are answering the questions in the exam, you need to use both, unless in the options, they have given you somehow, somewhere, an option that has a formula substituted values in it. Okay, so let's look at some of the activities that you can encounter in either your assignment or in your exam. Like I said, in this module, you need to be prepared for both worlds, the calculations as well as the theory. Which one of the following is not a property of a binomial distribution? Now, at the back of my head, you need to think about this because we spoke about this at the beginning of the session. Probably you have forgotten most of it. We said there are two outcomes. I'm going to say them haphazardly without looking at the options on the screen as well, just to give you a sight in terms of how you're going to answer this question. We said there are two outcomes, a success and a failure. They need to be mutually exclusive but collectively exhaustive. They need to be two independent events, and the number of trials will be the sample size, because those are the number of outcomes that can happen. Okay, and because there are two sides of it, let's use an example of tossing a coin. The outcome will be, for a probability of success, it will be 1/2 or 0.5, and the complement of it, which will be this probability of failure, will be 0.5, because it's 1 minus 0.5. Does it always have to be like that? No, it does not. Because if I roll a die has 6 sides. The probability of success that it will land on a 2 will be 1 out of 6. And the probability that it will land on other side except 2, it will be 5/6. So it's not always going to be 0.5, but the outcome, because there are two, it always can be a success or a failure. Okay, now let's see if what I've just said or what I've just saying to you, you can make sense of this statement. Which one of the following statement is not a property of a binomial distribution? 1, each experiment has n trials. 2, the n trials are independent of each other. 3, each trial has two possible outcomes that are mutually exclusive, which is a success or a failure. 4, the probability of success remains the same for all trials. 5, the probability of success is always 0.5 or 1/2, because there are two outcomes. Which one of those 4 statements or 5 statements is not the property of a binomial? Let's hear. Option 1, 2, 3, 4, or 5.
Lizzie, I'm gonna say 2.
Nope, it's not 2. 2 is also a property of a binomial. Remember, there should be 2 events or 2 trials events, one and the same thing. They are like pies in the peas or peas in the pie, and they are like same WhatsApp group, right?
Okay.
Okay, so which other one do you think it might be?
It's option 5.
Nope, it's not option 5. There are always 2 outcomes, a success and a failure. 1 divided by 2, because there are 2 outcomes. What else? Think about a coin and a die. Do they have the same outcome when it comes to success?
No.
Okay, so now, which one would that be?
Option 4.
Option
It
4.
will be option 4, because option 4 says the probability of success remains the same for all trials. It cannot, because if I've got a die and I've got a coin, this probability of success for each one of them won't be the same. It will be different. Okay. Let's move on to the next one. Africa Check found sources of fake news on Facebook that are mostly ghost profiles. Suppose 20% of the profiles on Facebook are ghost profiles. Suppose further that we randomly select 20 profiles, Facebook profiles, and check whether or not they are ghost profile. What is my probability of success on this? Let's start there. Remember, probability is always denoted in a percentage or a decimal. What is my probability of success?
0.5.
Nope. What is my probability of success? What is my pi in the statement? Only the statement. Don't look at the question. The statement.
20%.
20%. Therefore, you're going to say that is your probability of success, and 20 Facebook profiles will be your sample size or your number of events or your trials. Okay, so what is the value of the mean and the standard deviation? So it means you need to calculate the mean, or what we call the expected value, which is n times pi. And you also need to calculate the standard deviation, which is sigma, which is the square root of n times pi times 1 minus pi. Okay, so let's substitute the values into the formula and calculate. So for this one, our n, we said is 20. Our pi, 20 divided by 100 is 0.20. So what is the mean? The mean is equals to 4. 0.2 times 20 is equals to 4. The standard deviation? The standard deviation is the square root of your 20 times 0.2 times 1 minus 0.2, and that is given by. So if I take 20 times 0.2 times 0.8, and I get 3.2, and I take the square root of 3.2, and the answer is 1.7. And the answer is 1.788888. And we can round it off because the answers there are in 2 decimals. We can round it off to 1.79. And we can round it off to 1.79. Okay. Are there any questions? Are we good? Are we good? Are we good? Are we good? No comment. Let's look at, I'm gonna leave question 3 on its own. You can go through question 8 or question 3 on your own. If you have any question, take a screenshot. If you have any question about question 3, we can have a discussion on the WhatsApp group. Otherwise, I'm gonna move to question 4. So question 4, which is almost similar to what we just did. So we know that our probability of success is 0.20 and our n is 20. Now we need to find the probability for each statement. Number 1, it says choose one of the following statement, or which one of the following statement is incorrect. So we need to find the incorrect statement. Now you need to read the question with relation to the table with the signs. Remember that? So the probability that all 20 profiles are ghost profile is 0. Therefore, it means, what are they saying? It says the probability that all 20 profile, which is X is equals to 20. They say it is equals to 0. So what is the probability of X is equals to 20? It means you have to go to the table and go look for n of 20. So let me see if my table that I have here, oh, it doesn't also have 20. So I'm going to do the following. Discard. And I'm going to share my entire screen because we only have 7 minutes. So let's hope I'm not going to be sharing my other things that I was not supposed to share with everybody online. So let's see. So that I can toggle between two screens. The presentation and the table. Okay, we're on here. So let's bring the table up. Show you. Okay, we know that our probability is 0.20. Our n is 20. So going to the table. Don't know why it keeps on bombing out on me. Probably I need to bring it up and bring the table up. So I'm going to remove this. We are going to check. So our probability of success is 0.20. So if it's 0.20, it's at the top. So we need to go to 0.20 and our n is 20. So we also need to take care of that 20. So it means on the left, we're going to look for 20. And 20 is on the, okay, so it has three things. So I'm going to rotate. There's no anti-clockwise, so you'll have to bear with me while I rotate it. Okay, so we got 0.20 as our probability of success, and we have our n of 20. And the question is probability that all profile, the probability that X is equals to 20, which means exactly 20, all profiles, which is 20, and we go to where they meet, and where they meet, it's undefined. So therefore it means it will be equals to 0. It is mutually exclusive. It does not exist. So therefore there, the probability is 0. So question number 1 is correct. Number 2, the probability that no profiles are ghost. So what is no profile? No profile is 0. So what are they asking you? Find the probability that X is equals to 0. So you go to the table. We have defined our n and our probability of success. All what we need is 20. And that we just want X of 0. So which will be 0, 0,115. 0,0115, which is equals to 0,0115. So that is the same. So that is correct. So we're still looking for the incorrect one. The probability that only 13 profiles. So because it says only, so you're gonna go probability of X is equals to 13. And we go to 13. Here is 13, and we look for, I might not be using the correct thingamabob. Is it on the same? It's 0. So that probability is 0. The probability that I have all, like, all of them are correct. Maybe probably I'm missing some. Option 5, none of the above. The probability that only 12 profiles are ghost. So let's go see. We're looking for the probability of X is equals to 12. And that is 12. And we go with the line, and that is 0,0001. 0,001, which is correct. Now, the other thing, alternatively, it's because on this one, we need to be very careful as well with in terms of the since there are no other options. I'm gonna go back to that one option because it says all, so it means all of them combined. So it can be greater than, less than or equals to 20. So we can change that to less than or equals to 10, 20, and therefore the probability there will be equals to 1. Then it will make option 1 incorrect. And that one will be the incorrect one. So it means when they say all, they refer to less than or equal to that number, especially when it counts all of the profiles, all of them. So it means when it's 1, 2, 3, 4, 20, 13, 12, all of them. And therefore it means, because we know that the sum of all probabilities is equals to 1. Let's look at the one that I said you need to go and do on your own so that I give you some guidance in terms of how you will answer this. The first one is a theoretical one. You need to know the basic concepts of binomial distribution. Number 2 as well, and number 3 and number 4. Number 5, you need to be able to know how to calculate the probability of a complement. Because if we know that this is our probability of success, then what will be your complement event? Other than that, oh, hallelujah, hallelujah, you'll need to be able to choose which one of this statement is incorrect. And that concludes today's session. In a nutshell, those who don't know who I am and where I am from, my name is Elizabeth Boy, and I represent Pambili Analytics, where we try to bridge the gap between data literacy, numeracy, research literacy, and analytical skills. We offer a range of services, including our flagship skills development and training, where we are currently running a special on one-on-one consultation, 150 up until this month. After this month, we go back to 350. So book your session now before it's too late. Times are flying. People are booking. If you want to access the recordings are available on YouTube. Remember to subscribe, share, and like our videos. Even if sometimes the explanation it's too difficult for you to grasp, please like our videos and share our videos with others so that they can also benefit from the support that we are also offering. All videos that are accessible via the YouTube, they are for free. If you request access to today's session and other previous sessions, especially the sessions we started this year, you need to join the channel as a member, and you need to select either the loyalist or other membership title. The subscriber and the supporter and the promoter, the other membership will not give you the benefit of receiving your note and also the recording, access to the recording. On that note, we would like to also say thank you to some and most of our subscribers and our members. We really appreciate your support. Continue supporting us. Remember, we're doing this for free, but we're always willing to receive your support so that we can also try and push and create more videos for others. If you want to get hold of us, those are our contact details. Feel free to send us an email or WhatsApp, and we will gladly come back and respond to your question. Otherwise, enjoy your Tuesday evening. Goodbye.
Thank you, Lizzie. Goodbye.
Thank you, Lizzie. Bye.
Bye.